Alright, in this video we're going to address the configuration system for our game.
Okay, so what exactly is our configuration system?
Well, the idea here is that we want to be able to use an XML config file to store the settings for our game.
That's right. Now, this is kind of an extension of an idea that you may have seen previously if you've been watching some of our other videos over XNA. In our XNA 101 Extreme class, we took on the Space Fighter project. And in Space Fighter, okay, now I got to jump over to the blue board. In Space Fighter, we had a system similar to this. If we had a box that we just considered to be our game, then somewhere buried in a corner of this game, we had a special class called config. And this class had various fields that we used for initial settings on our game. Right?
Exactly. The idea here was that our game could simply look at this config class as the one place to which all settings were stored. Initialization settings, gameplay settings, anything that had some form of value that we wanted to store. It made the one place to store all values.
Now this has got pros and cons. A pro would be that everything is nicely contained inside the game. It's very easy to keep everything all enclosed in, but it has one major con. What's the con?
Well, in this case, since the field values were stored in the class itself, that meant the game's source code had to be changed if you wanted to change any settings.
That's right. No editability. If that's even a word. We'll go with it, though. I mean, it has a limited amount of editability, but it would require that you actually go in and recompile the game, even if you just changed a single setting.
Exactly.
So what we're going to do instead, and I need a much bigger eraser, so yeah, there we go. That's what I'm talking about, a big mean eraser. What we're going to do in this video is set up the first part of a system that will allow us to have a file. You like that, Dan? A little icon of a file?
Yes, very nice.
In this case, an XML file that will have all of this information stored on it. And our config class, it's still going to be there, but now it serves a different function. Rather than being there and just containing some hard-coded values, it is instead going to reach out and grab its necessary information from the XML file. So this way, somebody could go in and change some initial settings of the game, or any setting that you actually coded into the system, and then just start the game up, and as soon as the game launched, it will look for these settings rather than having to go into the source code and recompile a new version.
Exactly. The nice thing with the system is, as far as the game's concerned, nothing has changed.
Right.
The game itself doesn't have to worry about settings coming from a file or from magic or from random numbers. It doesn't care. All it knows is that fields in the config class have the necessary information. And then it's the config class that contains everything like a black box and says, okay, here's the actual storage mechanism, an XML file.
Right. Now, I do want to mention this as we're putting this together. This is not going to be a kind of system that you might have seen on other games. I'm just going to throw out Unreal as an example. If you've ever played much with the Unreal Engine, there are config files that you can dig through. They're ini files in their case. They're in XML in ours, but they serve the same function essentially. Where you could potentially delete out that config file and just restart the game and it'll rebuild. That is not what we're doing here. This is going to be an XML file that will be a required part of our game, and if for some reason this XML file were removed or deleted or didn't exist, that would be a bad thing, so don't do it.
Now, in this case, really at this level, the level at which we are working here in C#, that is something that could be added if you so desired. It's just, when you're looking at it from the programmer standpoint, that's almost like two different sides of a problem.
Right.
As far as the user is concerned, it's a very nice thing. It makes config files just like magically regrowing things that will reappear if you delete them.
Absolutely. The only reason I mentioned it at all is because I know there are some games out there that you might already be familiar with that have config files in any format you like, that you may have edited and be like, oh, well, it had a problem. We'll just delete the config and restart the game and everything's fine. That will not be the case in this game, and I just wanted to make sure there were no questions about that moving forward.
Exactly. Just the act of implementing the system should serve to demystify some of the concepts with configuration in general.
Well, let's get rolling.
All right, let's move back into Visual Studio, and let's get this scenario rolling. All right, the first thing that I'm going to do is, before we even address the class itself, is to actually get our config file going.
Okay.
The reason is, since this is really the interface to the user, or even ourselves if we change settings, The idea is that we'll make the config file first, and then we'll make a system in code that utilizes that format.
Now, for starting out, what is our XML file, our config file, going to contain?
Initially, it's only going to contain the screen resolution and a setting for storing whether or not we start up in full screen mode.
Okay.
It's going to start very simple. And the idea is that throughout the creation of our game, this config file can grow as relevant systems need to be configured.
Okay.
The idea here is that we have very few things we're actually going to store, so our config file will be very simple, but we can build all of the code elements around this file that will give us more power and make it easier to expand the file, make it easier to use different types inside of the file, and things of that nature.
Okay, well, just a couple of questions. At its heart, just real basically, for those who may not be completely in the know, what is an XML file?
Well, really, an XML file is simply you could say it's an open-ended data organizer and container. It's a data organizer and container in one. What I mean by that is, by nature of being a file, of course, you can throw data in it. Simple as that. Now, an XML file is broken up using tag-based markup.
Like HTML.
Yeah, it's very similar to HTML visually. And the idea is, with these tags, you're allowed to format your information. As a matter of fact, you can utilize a hierarchical data formatting.
Similar to a folder structure.
As a matter of fact, the different elements in the structure are actually called nodes. So you can define a section as being a high-level node. You can put some more nodes nested into this structure, and then you can put attributes or even values directly onto these nodes and thereby store value while retaining a very powerful structure.
Now, I will throw this out there. This is not an XML class. We're not teaching a class here on exactly how XML works, on every single part of the syntax and all the different flags you can use and all that sort of thing. We're going to build an XML file that meets our needs, and we're going to move on. But as we do this, I'm sure you're going to see enough where if you wanted to expand upon and start adding some nodes of your own to carry and deal with custom information, you'll have everything you need to know to do that.
Exactly. There'll be a few different ways or a few different kinds of data that we end up needing to store. I will note that the strategy that is used in actually storing data is targeted at keeping the file very compact and concise. We could store the information in various ways.
Well, let's talk about that while you build it.
Okay.
So let's go ahead and get started putting the XML file together.
All right, so the first thing is, where on earth does an XML file come from? Now, we could just start with a blank text file and begin writing the XML file from hand, or we could go in and create an XML file from Visual Studio and then repurpose it to the game.
Cool.
So we're going to do the latter. What we'll do is we'll jump up into our content folder, our content subproject, rather, and we'll jump down. We'll make sure we create this. Let me collapse up style here. We'll collapse up exact. And we'll create this just at the root of content. We aren't going to make a folder just for configuration.
Okay.
So here at content, we will add a new item. And this item will be a XML file.
Okay, that's nice.
We'll call this config.xml. We'll add this in. And we'll give it just a minute to process. And you'll see that we actually get a few things. What's happening here is the XML file in XNA is generally meant to describe some type of asset that you're importing. In our case, we're not going to do that. We're not going to bring an asset in. We're just wanting to leverage the XML file itself just for raw use.
Because it's going to store some random data.
Exactly. Some data that the content pipeline is not going to know about or care about. So what that means is we don't care anything about this content block, so we'll drop that out. Now, when we try to build the game, we'll run into a problem since the config file itself is set to be compiled. So we're actually going to change this over to a build action of none, and we're also going to change the copy to output to copy always.
Okay.
Because instead of using this XML file to describe a compiled asset, we just want a copy of the XML file thrown into our game, and our game is going to handle loading it.
Sure.
All right, back into the XML document itself. Now we can go forward and write the settings that we're going to use and also drop in the structure itself.
And this is where you might notice that some of the syntax that we use is similar in a lot of ways, but not exactly like HTML.
Exactly, because we're going to be using tag-based markup. So we're going to begin with our root element, and that is going to be config. So we'll drop in a config tag, and the end tag automatically gets thrown in. And the idea here is that this is the configuration file. So our root element is just config. Everything is going to reside every setting, every section, and every setting is going to reside between these two tags.
Okay.
All right, moving on from here, we're going to have the game's options. So we'll make an options tag.
Now, for the record, I'm just throwing out the occasional tidbit for those who don't get to work with XML files very much. You could potentially name these anything you want, right?
Exactly. All these names are going to mean to us later is the paths that we'll need to address the information.
Right.
We could name the root 3D Buzz, we could name the second one Drum Game,
right.
and we could start to establish, you could almost say namespaces, but really it's like a hierarchical structure.
Again, very much like a folder structure, putting almost like a folder within a folder. I just wanted to kind of throw that out there. You see us using config, and you know we're doing the config class. You know that this is going to contain game options, and we're naming this next set options. But you don't necessarily have to do that. If you can keep track of what your names are, you can use any name you like.
As a matter of fact, if you really wanted to, you could start dropping things right at the config level. Mm-hmm. The whole reason I'm even setting up an options section is we're going to have other pieces of information in addition to game options.
Right.
And so we'll use entire sections to separate those.
So we're kind of looking ahead a little bit.
All right, now that we do have the options section put into place, we're going to drop a handful of values down. Values that will store our screen resolution and an option for whether or not to start up in full screen mode. So we'll begin with the first, which is going to be screen res X. Mm-hmm. So we'll start a new tag. This will be screen res X. And we're going to store the actual data in an attribute. So as opposed to ending this tag off and then putting some type of data or a number like 800.
Yeah, this is where you were saying earlier that the formatting of this was going to be kind of set up more for keeping everything nice and compact than anything else.
Exactly. Since, of course, we would be free to store a value in this manner. What I'm actually going to do is use attributes to store any given value. So what we'll do is we'll make an attribute called value, since it's going to be the only attribute used in this tag, or in this node rather. And we'll set this to a value of 908. This will end up being a rather unusual resolution.
It already is, yeah.
This was simply put together to give the most screen space we could use in the recording environment.
Okay, well that makes sense then. Now, just to throw this out there, there's no reason why we have to put it this way. If we really wanted to, we could do this start tag and end tag version. It would just require a few differences in our code. We're doing it this way to keep everything nice and tight.
Exactly. Now, in order to end this tag off, instead of using a separate tag altogether, I'll just append this with a / to end off the tag, all in one set of brackets, once again keeping everything nice and concise. And now we can move on to the remaining values. As a matter of fact, since the rest of the values here for screen resolution and full screen are going to follow the same format, I'm actually going to copy this one line and then paste it twice, and we'll use this as a basis for getting everything set up.
Very nice.
So moving on from screen res X, we have screen res Y, and that is going to be a value of 681.
Again, just a number that we've decided utilizes our screen space really well.
Exactly, and of course, if you're following along on a larger monitor, these of course can be set to whatever you're most comfortable working with. You can set them to 8x6 just to keep everything nice and standard. You can set them to exactly what we're doing to follow along and get the exact result.
Anything will do.
All right, the final option we need to set up is startup full screen. And this value, instead of being numerical, will be Boolean. Now, the interesting thing to point out is that at this point in time, these pieces of data do not actually have type information associated with them.
Okay.
That's something we'll handle when we get more of our config class in place.
Okay.
So with these few values in place, we'll make sure we save out our config file. And for now, that takes care of the config file itself.
Well, it's holding our 3 bits of data, being the X and Y of our screen resolution and whether or not we're doing full screen, so we're done.
And now that we have our configuration format locked down, now we can begin building a configuration class to utilize this information. So let's jump into our game's code over here in the Solution Explorer. Let's go down to Game, and we'll add a new class to our game folder. We'll call this class config.cs.
See, the cool thing about working this way is that if you're coding something similar on your own, it's a lot easier to go ahead and just write out your XML file first to get a rough idea of the kind of information you need before you jump into your class, because then you can just tailor-make your config class to match your XML file.
Exactly, and you end up saving yourself some time in the end because you don't end up chasing your own tail, so to speak,
Right.
where you
Going
write the
back and forth.
You write the class first, then you save that information out. Then that information ends up being hard to load, so you make some changes. You finally change the loading method, then you have to change the config file, and you go back and forth a lot. It's nice just to say, all right, just from the standpoint of configuring the game, how would I want to configure out, just with the code out of mind altogether? Just what kind of options do I want to load? Throw those down into a file, and then once you've got that locked down, saying, yeah, yes, I like configuring this game in this manner, then code up the config class.
Very nice.
Now, to get things cleaned up a little bit with our solution environment here, we have a lot of source files open at the moment. So I'm going to drop a lot of these down. We'll close all of them down by taking our config tab. We'll right-click on it and say close all but this.
Okay.
Though we will bring back our config.xml file. So that way we can
reference it if we need to.
Yeah, just clean up our workspace a little bit. All right, beginning with the config class. The very first thing we're going to do inside of config is designate the fact that it is a static class. We're also going to clean up our namespace. We'll pull off the game subnamespace. Now, throughout the various things that we're going to be configuring, those will of course they will need access to some of the XNA types. And since we're going to utilize some of the XML functionality from .NET, we're also going to need to bring in the system.xml namespace. So let's get all of this put in. We'll make some using statements, and first we'll pull in XML, which is in system.xml. And then we need our XNA framework statement. So we'll grab using Microsoft.xna.framework as well as Microsoft XNA framework.graphics.
Okay.
All right, now we can turn our attention back to the config class, and we'll establish some fields. The first field we're going to drop in is the actual XML document itself, the XML document class that is going to be used to read the file. So this will be a static field. It will be of type XML document. Again, this is why we needed to open up that system.xml namespace. So up here we've got XML document, and we'll call this field XML config. We'll also go ahead and actually instantiate the field itself to initialize it. So we'll say this is equal to a new instance of XML document. Now at this point, this XML config, or excuse me, XML document object has obviously not actually loaded anything yet. It's just in existence and ready to go.
Yeah.
All right. The next thing we'll do is we will specify some fields. These fields are going to represent you could say the data interface that our game is going to be looking at.
Sure.
So whenever our game goes to look for values, it's just going to be looking for a series of fields.
So these should reflect the same things we've already put into our XML file.
Exactly. Another way to look at it is these fields we're about to write are the way in which our game will look at this config information. So like you just said, we need to make some fields to represent screen res X, Y, and start up full
It's the
screen.
interface point in our game.
Now, we will define all of these fields as both public and static. So we have public, static, screen res X and Y will be integers. And let's see, we have screen res X. And now we'll probably end up making heavy use of copy and paste because we have a lot of similar type and modifier scenarios going on. We just need to change a bunch of names. So we'll have screen res X, we'll have screen res Y. Now our startup full screen, we'll drop this in.
Well, obviously that's a Boolean because we had false in it before.
Right, but now we've designated this as strat up and change some naming.
Oh, that looked great.
Let's see.
Close.
There we go.
There you go.
Spelling is always fun when you're thinking in numbers.
Sometimes just blow it up and start over is better.
And of course, like you were just saying, this is going to be a Boolean value. Alright, and that takes care of our initial fields. Now we're going to put together a method skeleton to kind of outline exactly what this config class is going to need to be able to do.
Okay.
And just as a quick preview, all these are going to be both public and static. So as we go through and type these out over and over, I will try and make good and efficient use of copy and paste. Otherwise, we'll be seeing public and static a lot.
No worries.
All right, let's get started with the first method, which is going to be called setConfigFile.
Now, what is this method going to do? Go ahead and type it out first. I know it's hard to talk about one thing and type something else.
All right, so we'll put this down. We're not going to have any return off of setConfigFile, so we'll have void return type. Of course, the name, we'll have setConfigFile. We'll take in a parameter, and that parameter is going to be a string called filename. And we'll drop the method body in place. Now, setConfigFile. This method's job is to make sure that this XML document instance gets associated with and is told to parse the actual XML file. Because obviously at this point, we haven't actually loaded the config file yet.
Right.
So what setConfigFile is going to do is it's going to take in a file name. Again, because inside of this class, we're not very path aware, if you will. We've made other classes like global state to keep track of path type information.
Sure.
So we're actually going to be invoking this from the outside world where we do know about paths and files. We'll pass in the path to this config file, and then inside of this method we'll associate our actual XML document instance with that file. All right, moving on. We're going to have our next method. It will also be public, static, and void, no return. This method is going to be called loadOptions. And it does not take in any parameters. And the purpose of loadOptions is this is the point at which we will walk through the individual nodes inside of our XML or our config XML file and load each value by value, into these fields.
Okay.
All right, moving on. The next method we're going to have is getNodeValue. It's going to be both public and static once again, but this time it's going to have a return of type string. The method here, we'll drop in the name getNodeValue, and it's actually going to take in two things. GetNodeValue is going to take in an XML document and a path to a specific node.
Okay.
So we'll pass in our XML document. We'll simply call this XML document. And then we'll also pass in what node inside of that document we would like to look at. So we'll simply call this node path. And we'll correct a little bit of spelling with getNodeValue.
So this is actually going to dig through and find the individual numbers that are at a given location.
Exactly. We're told to specify, and real quick, just because it's bugging me, the error here, wanting to return, I'm going to very briefly put in a return of an empty string just to satisfy the requirement.
Okay. Yeah, no problem there.
Anyway, back to what you were saying. We're going to be looking at individual nodes, and the purpose of this method is to get values out, individual values out of the XML file. Now, the reason we're putting this method together, because the XML document itself has such functionality built in, but the problem is if we tell it to access a node that doesn't exist, we'll get a node reference back that is null. And in order to streamline the code, it would be nice to not have to consider or make if statement style checks line by line, value by value. Right. So what we're going to do is you can almost call this soft load value, where when we tell it to load an invalid value, we'll simply get back an empty string and can end up defaulting that instead of throwing an exception and crashing our game.
Gotcha. So between getNodeValue and loadOptions, and I imagine loadOptions is going to have to utilize getNodeValue.
Exactly. That's exactly what loadOptions is going to do. It's going to be calling upon getNodeValue to get the raw actual value in a more safe and soft manner. And we're actually going to need another set of methods on top of that in order to do the type reading to get from all of our different string values here inside of our config XML file.
Right, to kind of cast out to the appropriate type.
Exactly.
Well, so in general terms, our setConfigFile method is just giving us access to the XML file in general terms.
Yeah, basically just saying, there's the file, it's over there, load it up and get it ready.
Gotcha. And then loadOptions is going to start pulling those numbers out by using the getNodeValue to get the specific data.
Exactly. It's going to be using getNodeValue in conjunction with a handful of conversion, or we're actually terming these parsing methods.
Right. So the parsing methods that we're about to write aside, these three methods right here are the heart of getting information out of our XML file.
Exactly.
Okay.
All right. So we're also going to throw in the skeleton for each of these parse methods. And again, we'll put these all down first before we address them individually. Now, once again, these are going to be both public and static. The first method we're going to address is going to be called parse bool. So the type that we're going to be returning is going to be a bool. And the method name, we'll drop that in, parse bool. And parse bool is going to take in a string parameter called value. And this is just to match some of the semantics where we were working with an XML document looking at attributes called value.
Mm-hmm.
Now the idea with parse bool is, again, just to take in the string. In this case, we can even look at an example. Startup full screen is going to be a boolean.
Right.
Once we read this value out, it's going to be an actual string with the letters FALSE in it.
And then that will get converted over into a Boolean.
Exactly.
Now, in that light, that means that as of right now, all we should really need is the ability to parse Booleans and integers. Are we going to stop at that point?
Actually, no, because what you're saying here is we've only got screen res and full screen.
Exactly.
So
we've got integers for our resolution, we've got a Boolean for our startup full screen, and those are the only options we have. Now, are we going to stop at just parsing those two types, or are we going to parse some other things as well?
No, we're going to drop in a handful of methods. As a matter of fact, the types that we're going to end up parsing are going to be Boolean, integer, float, vector2, and color.
Okay.
We're going to set up parsing methods to address each of these types. And this should give us enough type conversion to handle options throughout the rest of the game. Since all these methods are very similar, very specific functionality, we're going to get that functionality out of the way ahead of time.
So you don't have to keep jumping back in here?
Right, then we won't have to keep making detours to put in individual type support.
Well, let's go ahead and get these all knocked out.
All right.
Now that we know what we're going to be doing.
All right, let's drop in. Let's see here. Matter of fact, I'm going to follow the same skeleton pattern we've been following, so all I'm going to put in here for code is just something to satisfy the return.
Return false? Or
yeah, just make a default return. Now, for the sake of time, let's grab this whole parse bool method, and let's paste it in an additional time for parse int, for parse float, for parse vector2, and for parse color. And we'll space these out just a little bit. And let's address some types and some naming. Of course, next we're going to have parse int. We'll return type int, and we'll call this parse int.
And return a 0.
Yeah, a good default value. Then we'll have parse float, which of course will return a float.
I never saw it coming.
And we'll return 0 again. All right, next up we have parse vector2. We will return a vector2, and we'll return vector2.0 for the time being as a default.
Okay.
Finally, we have parse color, and of course that will need to return color, and we'll return color.white as a default. Alright, that has the skeleton structure put together for all of our various parsing methods. And really that's what we're looking at in terms of functionality for the config class. So we're actually going to pause the video here, and we'll pick up with the implementation in the next video.
Sounds good.